This is the Amp Hour Podcast, released July 12th, 2020. Episode 500. 2.5 orders of magnitude.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Does it even matter that we're at 500? It's like
it's fun.
You know, it's a shoulder shrug. Come on, 512 is what we're after.
Okay, I actually did have that thought the other day. 512 would be a little bit more. But, I think the big thing about 500 for us, rather.
Yes, half a decade.
We average about 50 episodes a year. So we're getting pretty close. It's about, 2 or 3 episodes away from our 10-year mark.
Our 10-year. Because when is 10 years?
Our first show was August 10th, I think.
Oh, August, really? Okay.
Yeah, so it's like about a month away. Yeah.
Right. Yeah. 10 years. Geez, you get less for murder.
Yeah.
Yep. No, but can we name this one? It occurred to me, 500, half an order of magnitude.
Oh, that's good. I like that.
Yeah, you like it? Okay. Yeah, let's run with that because, orders of magnitude, it's a thing.
Yeah, that's what matters. That's how you should be estimating stuff. And that's great. I like that.
For you youngsters out there, I did a video on this, it was probably 10 years ago. It was one of my first 30 or something. And orders of how to impress at a job interview. It's like go in there and talk DBs and orders of magnitude. And you'll impress the hell out of people like you know what you're talking about. Now, that's, to the nearest order.
Yeah, I think, making estimates is good as long as you don't show too much don't show too much bravado about it, it's definitely this thing,
And you've got to, engineering's the art of knowing when something doesn't matter and when something matters. Right? Is when you need to be precise and when you don't need to be precise. There's no point. I know a lot of engineers who will be anal retentive about specifying their resistor down to, use the E96 range or something.
That's
and you don't just use just whaking a 1K, near enough.
Yep, totally.
Yeah.
Or they're paying a ton for 0.01% or, and it doesn't have any impact. And basically then their sourcing sucks and they're, it's
you're right.
expensive and it's a nightmare.
Oh, didn't I recently do a video? I'm always doing I did a recent video. God, I can't remember what it was. I didn't tear it down. I looked at an open source project and looking at how they had 60 different values of resistors on their bill of materials.
Oh, yeah. And you did a bomb optimization.
Bomb optimization, yeah. And it was, yes, tutorial PCB bomb consolidation, 1307.
Yeah.
And I think it was 60 different types. And it was and that would fill up a pick and place machine. A typical, just for the resistors. Yeah.
Yeah, and you were talking about lowering the cost of assembly and stuff like that.
Lowering the cost of assembly and lowering the risk as well of sourcing parts and stuff like that. Because, you can just risk goofing it up if you can't get these. Your purchasing department's going around like crazy trying to purchase 60 different reels of resistors and, they ran out. So you get a phone call at 2 a.m. in the morning from your assembly house because they're urgent, in China, and it's different time zone or whatever, and you get a call saying, oh, we ran out of 1.02K resistors, and it's is it okay if we use a 1K?
And even if they have to call and ask, that costs time and,
of course.
Your sleep and
the line stop and the production line stopped, and that means you can miss a deadline, and bingo, things just have a way of cascading out of control, and into big delays and stuff like that.
Yeah.
Speaking of delays, can we get into the you cannot buy an analog discovery?
Oh yeah, that's from Vigilant.
Can't get them, apparently.
Yeah, they wrote an email about it already. Did we link this post as well?
Yeah, it's on the Reddit.
Yeah, and so Caitlin's one of the product managers. She is the product manager for Analog Discovery, and I talked to her about it a little bit. And it's just all their stuff is tied up in medical and, a lot of getting the parts. That's one problem. The other problem is you think about every single engineering department in the country, at least in the US, probably a lot more. There's a ton of educational material around this. And they all basically are oh shit, we need 200 analog Discovery 2s
Yeah.
before September, and they're all trying to buy them at once. So yeah, I don't know. I actually gave one to I was working with someone who is a software person, and I gave him my analog Discovery 2. I used them for contextual electronics.
Yes, I had two of them. I gave one away as well, and yeah.
So I gave mine away. This is like my travel scope, like that's what I take and I use a lot. And so I was
That's
like, oh
great.
my God, I went on eBay and just like bought one. Just like luckily
Right.
someone was like, oh, I don't do electronics anymore. They just sold
Yeah,
it to me
sell it a
cheap. And
second
like,
hand. Yep. Yep.
yeah. And so keep an eye out on eBay. That's a market that's, my goodness. It's yeah.
Mm.
I mean, and it's just like you think about all the education, right? We're in July, right? So, we're 2 months away.
2 months away from what?
2 months away from a new semester, maybe even less. I guess even
Oh,
less,
it's
really.
actually less here. Yeah, they start in July here. Yeah.
Oh, they do? Okay.
Yeah.
Yeah. So like,
Unless it's a tri-semester, unless it's a tri-semester based one, which some universities in Australia are. They've moved over to the when I was a boy, there was none of this tri-semester rubbish. It was, but no, a lot of courses start in July right now. So
yeah.
Good
And
luck.
but like you think about the supply chain, even if everything else was good, you got to get all of these out to all of your students. And it's like, I mean, so we had Brock on the show. Brock Lemiris was on the show 3 episodes ago, and he was talking about some of this stuff, and he's doing like embedded remotely, right? And that's like with dev boards, which is good. But like when you start to like move out of the digital realm into the analog realm, like, oh my God, what are you going to do? Like you need something like this, or you have to like then refer people to like your video and, your video about like putting together a lab and be like, well, good luck, buy all the components too. It's like, oh, it's just a really big ask for students,
Oh, it is. And this is something that David too was into. He used to work at the University of Technology. He was he did some tutoring there as well as he was basically working in a lab. He was actually designing all of the educational kits and things that these kids, some of them were quite complex, right? They're like, 4 or 6 layer boards there, and fairly complicated, lots of parts to do all sorts of various, examples and demos and things like that. And he was getting like hundreds of boards made at a time.
Yeah. I mean, the scale of education you not only need for all the students,
yeah,
but you have to imagine a bunch of students are going to blow them up too. So you need
some
backups,
yeah, exactly. You got to buy more, and each student needed one. And it was like, and you got, and especially in the different stages of the courses and things like that. And you needed they were doing like runs of 500. And he was saying like sometimes he was like hand assembling these things, working late into the night, hand assembling or hand finalizing or whatever hundreds of these kits and testing them and make sure they work.
Yeah.
And it's that sort of awkward number where you start putting effort into designing automated test jigs to actually test the boards and things like that,
right.
because you've got to make sure they all work so that, so that the lessons can work. You don't want some student, well, I do personally. I love it when things fail because that's when you learn the most, of course. So, oh, great, your board doesn't work. Fantastic. Let's troubleshoot it. You might actually learn something during your degree. And
yeah, but doing that times 100 or 200 is, I mean, like,
it's a lot. It's a lot of effort. Yeah. And
and if it's the equipment that's not working versus like the experiment, that's something else entirely. So
have I told the story?
Well, the 500 episodes in, yes,
probably. I've probably stolen. Someone will remember that. Oh, yeah, he did that in episode 82. And I was doing like a digital. I think it was a digital. Yeah, it was a digital logic class, and we had this, breadboard. We were building up all this breadboard. Breadboarding up some complicated, digital thing with a dozen TTL chips or whatnot, and it was adders and device. It was doing all sorts of stuff, and we were building this up, and nobody's worked. And I'm like, and before I build it up, I'm looking at the circuit, and I'm going, this probably isn't going to work. And because anyway, everyone built it up. It didn't work, but I went so I built it up as per the schematic, but I knew this probably wasn't going to work. And sure enough, it didn't work. And then with minutes, I had it fixed and nobody else had theirs fixed. And mine was the only one working in the end. What was it? It was a fan out. We were using 7.4. I think we were, might be showing my age, but I think we might have even been using like 7.4, not 7.4 LS. I think it was like 7.4 series logic. Anyway, it was a fan out problem. We had one gate driving 12 others, and I'm going, I don't think this is going to work. And and sure
Just
enough,
because the drive strength, you mean, and like getting all the way across the board.
Yeah, it's like nobody had tested this, and sure enough, it didn't work. It only had a fan out of like 3 or 4 or something like that, and it just didn't work. If people don't know what fan out is, it's chips have a certain drive capability. They can drive a certain amount of current whilst keeping the minimum low and high threshold levels required. There's high drive and there's low drive from the totem pole output, and it can drive enough current so that it can drive all the inputs to all the other chips. And this isn't a problem on CMOS. It only becomes a problem on CMOS when you have actually capacitance on the line, where the capacitance becomes the load at
big
frequency
cable or something.
The long wires, all the input gates have X amount of capacitance and stuff like that. Because essentially, a CMOS device is infinite input impedance, essentially.
Right, except for with the Miller thing we could talk about. The Miller Plateau.
Oh, we could talk about the Miller Plateau, yeah.
Right.
And we'll segue into that one. And it sure enough, it didn't work. And to my and apparently we ran out of time or something, and they just passed everyone. It's like, you got to be kidding.
Oh, no.
Mine's the only one that I was pissed off. Mine was the only one that worked. I was the only one that figured it out, and it was like, but everyone passed anyway. I was like, come on. Anyway, yeah. So,
but you're not holding a grudge all these years later. That's
not
holding
a grudge. Yeah. Anyway, that one sticks in my mind.
Yeah, right.
It's like, and they wouldn't believe me. They wouldn't. I think the thing why it sticks in the mind is because they wouldn't believe me. They went, "Oh no, it's a fluke that yours is working. We don't know why yours is working." And it's like, no, I can tell you, it's the fan out. And I tried to explain, and they wouldn't believe me that fan out was a thing.
Who was they in this case? Was this someone who was actually
I can't remember I can't remember if it was our actual lecturer, our digital electronics lecturer, or whether or not it was like a assistant, what's the name of the
grad
assistant?
Student or a teaching assistant?
Like a teaching assistant, grad student or whatever, because it was just a lab. So it might have been just a teaching, but these are graduates, right? These are, usually.
I don't know.
Aren't they?
Yes, I mean, I'm not saying they're not capable. I'm saying it's more of a, if you're not writing it, you're just like, just do the lab, man. I'm just trying to make money.
I know.
Here.
It's just man. I'm going for a smoko afterwards, just to finish the lab, man. Come on. It's like,
I mean, they got other things going on,
of course, and have to get to the uni bar,
That's right. That's yes. Yep.
Oh boy. Anyway, yep.
So Miller Plateau. This is a thing that James, the bald engineer, did a video about. It was pretty good. It was basically showing the effects of Miller capacitance, and basically when you don't have any, basically saying, hey, throw a resistor on the input gate to a capacitor,
a FET.
A FET, yep. And it was interesting to see the actual traces, and he actually shows how the traces change and what the inputs look like as you change the resistance out. So it was a pretty neat explanation. I guess I've read about Miller capacitance, and I've looked at it, but I've never really seen it in practice because I usually do have either inline resistance from a PCB, or there's actually a resistor there and stuff like that, or I just
most people, and it really comes into its play in power MOSFETs, and so unless you're doing really power MOSFET-y, big grunty driver type stuff like motor drivers and stuff like that, that's probably not gonna come into play. So anyway, the Miller Plateau is where you charge. I'm not big on it, but it's where the gate charges up, and it's at certain VGS threshold levels. It instead of continuing to ramp up, it actually plateaus out. The charge actually plateaus out, or something like that. So, yep, I'm totally butchering that. I'm totally butchering it. It's been a long time since I've looked at that. So, yep, and I haven't seen the video. So I'm sure if you watch the video, I'm sure it's all explained.
The real problem is, Dave, that you're spending all your time watching other stuff like Amazon Prime movies.
You had to bring this up. You said you'd bring this up at the start of the show. I don't know why.
I think it's because... Well, so here's the thing. I catch it on Twitter because you're like, oh, I spotted an oscilloscope. And that's kind of interesting. But then sometimes you post the videos, the movies that you're watching. I'm just like, what the hell is he watching? And I will tell you, I used to watch stuff like this. I used to go over to my buddy's house. His dad had a collection of like 1980s, like really terrible sci-fi, like the worst grade stuff you could get, like Plan B from Outer Space, but like
Right.
times like he
Yeah.
like collected bad stuff, and so we used to go and watch that stuff.
Right.
So I'm not against it per se, but because you do it, in
I
public.
don't necessarily watch them all. Like I didn't watch that like invasion from Mars, this Japanese invasion from Mars from 1970 that I tweeted the other day. I didn't actually watch that one in the
there's
end.
some real bad ones out there, like what got funded. I guess they're low budget anyways, so it's not that big a
they're
deal,
super low budget. I wonder how much it cost Amazon Prime. Probably nothing. Like, pennies on the dollar for.
Oh, I bet nothing at all. I bet it gets. I bet that gets thrown in, but basically it's like the throwaway from the,
right.
From like
the studio.
the movie.
Because you sign up for studios, don't you? And then you get all the
exactly.
I think something like that, and you just get all. So they paid the studio X amount, and they got 1,000 B grade.
Yep.
Oh man, just to say, oh yeah, we've got 10,000 titles on our streaming platform, and you go and actually watch. But there's so many now, so many streaming platforms. Before, like when it, like what 5-7 years ago, it was Netflix, and that was pretty much it.
So I saw an image the other day that yes, that's correct. I mean, it was not much. I saw a image the other day that said like it showed like different streaming platforms and like their various costs, and it was like Netflix $120 a year, or Amazon Prime $99 a year, and I kept on going down the list, and then at the bottom it had Harvard $50,493 a year, because it's like because it's true, right? All of these schools is basically like this is really, really expensive streaming service, which is like kind of messed up. I don't know. I think if we have students listening out there, I'm sure we do. I feel for you. I don't know what the hell I would do in your scenario. Man, it's just keep making stuff. That's the important thing. That's like all you can do these days, because it's...
What situation are you talking about? You're talking about that everyone's
it's
doing
like universities. I wouldn't have. I would burn out. I would just end up watching TV all day instead. Like if I was just if I had to if I didn't have the in-person element of it, I would
if you physically weren't there, you would.
Yeah, I just wouldn't lock in. I wouldn't.
Yeah.
Yeah, exactly. Yeah. I'd be a slack ass. Yeah. I mean, like I'm okay now because I'm like into it. But like when I was when I was younger and frustrated with a lot of things, not frustrated with a lot of, like when I was learning,
just young.
Learning is tough when you're on your own. It's like, it's a difficult thing. So
this spills over to the gym. A lot of people ask, do I do weights like at the gym? No, I do classes, because if I just wander in the gym on my own and try and do just free weights, I'm just going to be a slack ass, Whereas if I'm in a class with 10, 20 other people, wow, I just go berserker, right? It's it's an interactive thing. It's like, and it's almost a competition too.
Yeah, there's the competition aspect for sure. Yep. Yeah. It's just a tough time. I mean, I think I feel, especially for people that are getting started, like it's, I don't know. And like, there's so many things that people could learn too. Like that it's like, there's like this like underlying guilt that people, like some people are just like depressed, and, it's tough to get anything done these days during, lockdowns, if people are still in that. And it's like, I don't know. It's like, it's just a real tough time for learning, I think. So.
Well, here you go. I didn't say this is not on the list, but I will send you the link to this. There's just came out the other day, big news story. It made all the rounds here. Almost half of Australian PhD students considering disengaging from studies due to the pandemic.
Wow.
This is like it. They reckon 5% of PhD students in Australia are currently or about to experience homelessness, and 11% are skipping meals. It's like,
that's really messed up. Yeah.
Wow.
I mean, PhD students live on the edge anyways. It's like such a low payment, like stipends
it is,
are usually
but
low anyways.
Like most, like I don't know what's like in the US, but here in Australia, the tradition is that when you study, you don't go to university to study. We've talked about this many times. You like stay at home with your parents. That's the way it's done. And like the parents are going to feed you, and you don't have to worry about getting that second job, to pay for your, rent or whatever.
Yeah.
The whole dorm thing is not a thing here in Australia. It's only for overseas students. So I find this remarkable.
Yeah.
Really?
Is that also the case for PhDs? Do you know? I mean, like, I don't know if you would have.
Well, I assume. Well, I don't know. I've never done a PhD. I don't know about that sort of crowd. But
I got a PhD in the School of Hard Knocks, right?
School of Hard Knocks,
right?
exactly. Word. Yeah. And I find that really remarkable. These must be overseas students.
Maybe,
Well,
but still,
but
yeah.
overseas students, they'd probably have their parents paying them to come here, usually. So I just find that remarkable because we have such a culture of staying at home.
Mhm.
And that
Yeah.
and that actually determines which university you go to here in Australia. It's like, well, which one's closest to home? Do they have a course I want? Yep, I'll
See,
go there.
that's the thing that I don't get about that whole system is like, what if it sucks?
It doesn't matter. See, people don't care here
Yeah, it
because
does.
no, unlike the US, it is not when you go into the job market, it's like, do you have a degree or not? It doesn't matter where you got it. It
Uh-huh.
really unlike the US is much more tribal in that respect.
Pedigree,
It's like
yeah,
pedigree,
right.
tribal. Yeah, here it's like,
Yeah. Yeah,
nah,
okay.
nobody, no one cares. It's
I mean, I guess I shouldn't
uh,
really say that it matters anyways because I'm kind of like, oh, you shouldn't. School doesn't matter that much. Uh, but
right,
yeah, I I guess it's so ingrained in my brain. Well,
right,
we've
yep,
talked
yep.
about that many times. So,
Uh-huh.
huh? Well,
So
I'm feeling bad for all
yeah.
the PhDs out there, and I'm sure it's not just
In
Australia either.
Australia.
So,
No, it
yeah,
could
it's
be, maybe it's
yeah,
elsewhere as well. But yeah, I just
mm.
I don't know if the article how accurate the article is.
Sure,
It's from the
sure, yeah,
Guardian. It's like I don't
mm.
know, but but yeah, that's really remarkable. So please, if you're a PhD student, leave it in the comments down below. Like, do you
Yeah,
know other students struggling
yeah,
to make ends meet?
yeah. And so like some of it, I think like people can do amazing things at home and on their own as well. And like I think I'd like to bring up some of the tools that are doing these kind of that are like enabling these things. But like I said, it's still tough to do that. It's still tough to get motivated to actually go out and want to learn these things. But like it is
Mm.
kind of amazing. On the flip side, I suppose it's
Right.
kind of amazing what's now available. And so we're going to talk about more about this next week. So Tim Ansel is going to be on the show again next week. But one of the big stories is that Google is the new open source PDK, and then Google's offering
Yeah.
free fabbing for 130 nanometer chips. So next week we're going to talk to Tim about that. What did you think about this whole thing, Dave?
Can we repeat that? Google
Sure.
is offering free semiconductor wafer fabbing for 130 nanometer technology, free for open source chips. It has to be an open source chip.
Yep. And it's got to be on GitHub, I think, or GitLab or whatever.
Right. And so is this available to anyone? Do you have to be like, I haven't looked into the details. Do you have to be like a university like, do you have to be like
Nope.
no, you can just be in your,
You have to apply, and then you have to be.
you got to apply. Right. So it's not
Yeah.
automatic. It's not like, hey, it's, right.
Yep.
So, and does it have to be substantial? Will they do, hey, I'm going to do an open source 555 wafer chip, and will they accept that or not?
You have to design it. I mean, I
of course, you got to use the tools. And they're offering the free tools, right? Because the tools aren't normally free. Is that?
The tools are free. I think
tools are free. Right.
I think so. I think this is using Electron. Like I said, we'll find out more next week. Tim will be on the show next week.
It's called the Skywater PDK, which is
which is the fab itself, the foundry rather.
Yep.
So Skywater Foundry, the PDK is the process development kit. And so basically, we've talked about this a little bit on the show in the past, not the open source nature of it, but basically, once you get access to the PDK, that gives you like, oh, here are the standard cell transistors you have access to, and then you can start to tweak some parameters, as far as I understand, at least. Again,
so what software does it come with the software to actually lay out the components, or like I just don't know. I've never designed a chip. Like I've never actually at the silicon level. I don't know the tools. Is there another tool that is this just like the library and you have to then use your silicon CAD tool of choice, or?
Yeah, I think that would probably be a good way to make an analogy. It's like this would be like someone handing you a library of footprints and symbols.
That's right. Yep.
You have to plug it into a layout program.
A layout program, right?
That has all of the DRC checking and all the and it does have parallels as far as I understand it. There is an open source one called, I want to say Electron, but I don't.
Oh yeah,
know if that's
I
right.
think that
We've talked about one of them on the show before, and it's real ugly, and it was real ugly last time I looked at it. It was all Java based, and it was real ugly looking.
Right.
But I think it's still alive, and I think so I think that's one. And obviously, then there's also like Cadence, which is like, okay,
Yeah,
well,
but who's got access to that?
who's got
Right?
50
I
grand
mean,
sitting around and then being like, oh,
exactly.
okay.
50,
Yeah.
50, it'd get
Well,
you the bare, well, get you the
50
bare bones. Wouldn't
starter.
even get you
Yeah.
the bare bones, would it?
Yeah. I don't know.
Yeah, it's like,
But I think the
geez.
PDK is like the plug-in piece that then basically is
Right.
like the
The
footprint
library. Think of it
Yeah.
as the footprint and component library. Yeah.
Yeah.
Which has all the, yes, here's a flip flop. Here's a, here's a MOSFET.
Mhm.
Here's a, yep.
I mean, here's a single transistor, honestly. I think that's some of it too.
So what is this process node capable of? Is it capable of like analogy stuff? Like, is it capable of mixed signal, or is it?
It is not. It is not right now. So
It is not. So it's digital
Tim
only.
talks about that a little bit in the dial-up talk. So that's the linked video in there.
Yep.
It is digital only right now. I think they're working on an
Got it.
analog solution.
Okay.
But I think
Right.
I'm pretty sure it was no analog. There are, you can have like inductors, capacitors, like all that kind of stuff. But
right, but you really wouldn't need those in a digital design anyway. Really,
Yeah,
apart from pull-ups and
right.
stuff like that, and
Yep,
other
exactly.
open drain outputs and
Mhm.
inputs
Yep.
and things like that. So could you take, like, if you had an existing VHDL design, could you just like import that, like, and compile that to your own custom silicon? Is that possible? Do you have to even use?
Yeah. No, you do have to. I mean, you need a tool for it, right? You need some kind of like placement tool, right? Let's place and route does, right? But I don't think you would take like a VHDL, or sorry, you wouldn't take like the placement file from like a FPGA tool and then be like, oh, I have a chip now, right? Because that's,
no, of course. But if you had your VHDL code, right, could you import that into one of these layout tools, and then it pulled the libraries in that it needed, and and then it mapped, oh yeah, here's a shift register, and it maps that in. Here's a flip flop, it maps that in, and then we just don't know. We have to use the tool.
You lost me about 5 minutes ago. Yeah. So next week we'll have all this and more in episode 501
Will be
with Tim
answered.
Ansel.
Right.
Yeah.
Fantastic.
But it's interesting. I mean, like, it's an interesting time at the very least. I mean, the fact that Google's doing this, and the fact that it's it's driving open source forward, which is interesting.
Yep.
Someone, who was it talking about it? But it was interesting, like comparing a Google versus an Apple, right? Both are talking about chip design, right? Apple now has, and Google's done chip design as well, I believe, like internally, but like Apple's going like more closed, which is kind of on brand, and Google's like, well,
they're
open.
switching to ARM, but they're doing their own variant.
Right. They're doing the design, like, right? Exactly. It's not like Apple was open ever, but I'm just saying that, like, they were. Exactly. I forget who it was. They were comparing the two, and it was interesting, like contrast.
Right.
So we like the open stuff here. That's great. So we'll see how that all goes. I mean, I don't know.
Can I mention my prediction I put on Twitter here?
Sure.
That Apple, I made the prediction that Apple are going to buy a semiconductor company in the next couple of years.
Oh, interesting. Okay.
That is my prediction, because they need to vertically integrate more, and Apple's all about profit margin, right? They've got $200 billion in cash sitting there, right? And they usually use this cash. The reason that Apple makes such great margins, they're such a profitable company, is that they use that cash that they've built up to buy, 100 million processors, right? They 100 million memory chips, right? They buy up years worth. They buy up entire production lines worth of chips, right? So all these memory makers, they'll just be churning out chips for Apple because they're, so they use it to get volume discounts, right? Mm-hmm. So the next logical move from that,
I think this is the opposite of logical.
Well, why?
Because why would you take on that risk then? I mean, like, basically you're throwing your weight around. You got this huge club that you can, hit people over the head with, cash
right, called
availability.
Cash,
and then you're like, maybe I should hit myself over the head. I don't know. Like, chip fabs suck, man. Like,
yeah, but the chip fab keeps running itself. I'm not talking about them starting up their own chip fab from scratch. I'm talking about buying an existing player and because and let them run it, continue to run it how they were, but they don't have to pay any margin on top. So it's, Apple's all about margin, right? So they would get the chips cheaper than everyone else because they own the company.
So you're saying cheapest chips? Cheapest chips.
Anyway, that's that. I would not be surprised if that's happened.
Okay. It's interesting. I mean, it's an interesting idea.
I probably wouldn't bet money on it.
It's very wonky, but
it's not wonky. It's like, it'd be a big.
No, not wonky is bad. I mean, it's like you're like a wonk.
Right.
Like, this is a wonkish opinion.
No,
A wonk
I
is
don't
like
know
an
that
expert
term.
who like a
No.
political wonk is someone who like basically analyzes the political spectrum
Oh,
and then yeah, it's like a wonky is
okay.
like a is usually like a
Okay.
negative connotation, but to be like wonkish or to be a wonk is to,
Oh,
someone
okay.
who
I
like
haven't heard wonk
analyzes.
before. I've just heard
Yeah.
wonky. It's like
Yeah.
it's
That is a negative connotation.
like it's
Right,
going to fall apart. It's wonky.
right.
So, interesting. Okay. Anyway, so that may or may not come true. So if it comes true, damn it, I'm going to say I called it. And if it doesn't come true, everyone will just forget about it.
Okay.
So the
What?
great benefit of making
Who was
predictions.
that? Who was that? Yeah, right.
Nobody ever looks back and your prediction was shit. So
yeah.
Anyway, yeah. I just think it seems to make sense because Apple's all about screwing those margins. So yeah. Anyway, that'll be interesting if it happens.
Yeah.
What else we got?
I'm looking through this thing now. Let's see.
Such professionals here on our 500th episode. Oh, talking about the open source thing, we can segue into the open source thing. There's a new DIN standard for open source I don't get this. I downloaded the zip file.
I don't either.
Okay, it's open source hardware requirements for technical documentation. It's been released. It's the DIN spec 3105 for those playing log at home. And I downloaded the zip file of the, that was posted on Twitter by, who posted it on Twitter? I can't remember, sorry.
Jeremy Bonvoisin.
Okay.
Bonvoisin?
Good on you, Jeremy. And I downloaded, and it's got like, well, there's the hardware symbol and there's this .md file. What's a .md file?
That is that's a documentation file in Git.
Git,
if you have
right.
if you have a .md, it'll show as the first. That's like the cover page. So usually it's readme.md.
Okay. Oh, okay. So it's just a text file, is it?
Yep. Yeah, it's like a markdown. That's what it is. .md is markdown. Sorry.
Markdown language. Right. Got it.
Yeah.
Got it.
Yeah.
Okay. Right. I need to extract this right about now and stick with me for a minute. I'll get it.
Yeah.
And
well, while you're doing that, it took me a long time to find out that DIN is German coming Deutsch Institute for Normung. Sorry.
Something like that.
I'm sorry. I'm so sorry. But that's what I never knew. So I always knew the term DIN rail, but I didn't realize it's actually a standard that comes from a standards body in Germany, and that's what DIN
and a
is.
DIN connector and
what's a DIN connector? I don't know what that is.
A DIN connector, the 5-pin DIN connector. The old keyboard connector from old school PS2. Old PC keyboard. That's a DIN PS2 connector.
I didn't know that. Okay.
No, not PS2 is a mini DIN or whatever. It's a DIN connector is your traditional, circular plug.
It almost
looks
like a MIDI connection.
It's a MIDI connector MIDI. is a DIN connector. Yeah.
Oh, it is. Okay.
I think. Yeah.
So it's basically like the outer. So it's got like a circular outer shell and then like.
Yes, and multiple pins in there. Yeah, that's the DIN standard. Yeah.
I think this might have been pre-Chris.
Okay, right, pre-Chris. Yeah, this was like this is like 70s era connectors.
Chris was either not existent or too young to be allowed to unplug things.
Basically, if you look at every vintage PC from the 70s and probably up to the mid 80s, DIN connectors were the thing. They're what your keyboards plugged into. Serial, you'd even get a serial DIN connector. None of this D9 rubbish. It was or D25. It was
right.
It was
something
DIN,
that can make a DB9 look small.
yeah, exactly. It was that was the thing.
I'm
because
not sure
they came
that's gonna hold on.
on.
Let's get a little bit more steel on that. DIN 476 is international paper sizes. Wow, they really do a lot of stuff. That's gotta be a tight ship. Can you imagine working at a German institute office?
Oh
my goodness.
German Standards Institute.
Oh boy. Yeah, I just
sorry to all you Germans out there, but we're stereotyping.
Yeah, we love you. It's just like that must be intense. Not bad. It's just intense,
But I'm sure it actually produces the finest standards out there.
I'm sure it does. And so the A series, so DIN 476 is the A series paper sizes, which the US still hasn't adopted, which is stupid. But
it's dumb.
We still have letter and tabloid.
That's so retarded. Yeah.
Yeah, it's not great. It's 8.5 by 11 though. That's Yankee units.
8.5 by 11. Yeah, what?
Freedom
Inches?
units.
Come on. This is
Inches,
ridiculous.
that's right. Yeah.
Get with the program. It's just, no, like A's are perfect. Like an A1 is half the size of an A0, and A2 is half the size of an A1.
I mean, let's just start at metric, Dave. Come on. Let's get
right. Small steps.
I think we have lots of things we could point to that are a little off around these parts. So, anyways, you were saying, so, okay. So I think the thing is, I think the reason that this is interesting from a high level is that it's, a German standards body, and now it's open source though. So people can contribute to it.
Yeah, okay. I'm reading it and I do not know what I'm reading. I seriously, I have no idea what this is trying to do.
This repository holds open standards in the field of open source hardware.
To the corresponding documentation.
I think this is basically trying to make, so like there's open source hardware summit group, OSHWA. They also have, standards and stuff like that.
They've got their own, thing
and so I think this is trying to standardize in that same way, but through DIN.
Right. Yeah. It's just like you read it and you go, you just go, what?
So here we go. DIN Spec 3501-2 defines requirements for implementing a community-based certification procedure for open source hardware. Okay, that's cool. DIN Spec 3501-1 delivers an unambiguous and operational definition of concept of open source hardware and breaks it into objective criteria for judging the compliance of a piece of hardware with this definition. So basically, this is just another way to say, is it or is it not open source hardware? If it is, here's how we certify it, I guess.
Yeah,
what happens though if you can you fork a DIN spec now? That's kind of interesting.
I don't know. But it's just so wordy and weird, and it's seriously, people have to go check this out for themselves because it's quite. I've got to sit down and actually you really have to concentrate to read this. It's not something I can do while talking at the same time. My brain just doesn't have the bandwidth to do it.
Yeah. I think someone brought this. I think when I was in Germany for Chaos Camp, I think someone brought this up. I remember hearing about this at some point, and it was in process. And I'm sorry if that person's listening and they were telling me, and they're like, "Chris is going to remember exactly what I'm saying." I did not remember.
Yeah, right.
So, it's okay. Well, we'll see. We'll see. I think it's just like any other open source hardware. It's it's only. There's always a lot of struggle around it, a lot of people want to get it right. They want to make it standardized, and that's what a standard is, right? It's like it has a set of definitions and people agree to it, and it's community certified, blah, 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 blah. It kind of now that it's there, I kind of forget about it. So that's just my personal, it is important, but it's just I've just kind of forgotten about it. And now this is a new one. And I'm sure once it's standardized, I'll be like, oh, okay. I've forgotten about it.
But as with open source hardware, most people just shrug their shoulders and just don't care. They'll just do whatever they want. It's just man, just throw some random license on it.
It's great that people are doing it. Yeah.
It's
great that people are doing it. And I feel like there's always these things. I see this with some of the software podcasts I listen to, and sometimes I see this in the firmware projects and software projects that I follow. There are some very real implications. I never run into them because it's not I'm not doing big enough software projects that it matters, but I can imagine a scenario where it's some of the licensors are no, if you have this piece of code in your software, the rest of your software is open source. And it's that. Oh my God, that's a huge deal.
That could be a legal minefield for company. And it is there's been lawsuits about this sort of stuff, you know?
Right. And so I'm just grateful I don't have to deal with it. That's what it comes down to.
Yeah, I tried to do my own little. It wasn't a standard, but I tried to come up with a new concept for open source.
The seven thingies. What has to be open about it?
Yep, and the Creative Commons. It was kind of making open hardware sort of like the Creative Commons letters, to have it, like the CC BY,
Yeah.
That sort of thing. The same thing for open hardware, and there's quite a few people who have taken that up and actually continue to take that up. They actually put the little letters on their, logo and stuff like that. which I still think it's an excellent idea because at a glance you can tell from
do
the
you,
logo
Dave? Do you
what
think
people are giving
your
away.
own idea is excellent?
Yep. Damn right I do.
This is
solves
very surprising.
Real problem. It solves a real problem. Right? It does.
I have
the
dog in the
standards
race,
are
Dave.
one thing. Standards are one thing. Okay, and
you
then you have real world problems.
Or
come on.
Iconography. That's what you're talking about.
Yes.
You're talking about iconography.
Yes.
Yeah.
There are real world problems that people need to solve. And one of those is what people are actually releasing and making open. It's like, they will stick the logo on it.
Here's where Dave gets his PhD. This is what Dave goes back and he gets his PhD in this thing, whatever it is. And he just goes to conferences and argues with people for the rest of his friggin' life. Dr. Jones. Yeah.
If there's I'm an engineer. Sue me. If there's a problem out there, I want to solve it. And one of the problems is people you can't tell what they've actually released. Right? It's like, how open is it? They've whacked the logo on there.
I've been waiting to say this for years, Dave. I'm going to say it right here. Okie dokie, Dr. Jones.
Oh, boy. Anyway, yes, it's a serious problem, at which none of the other parties want to address. Quite frankly, they have the purest approach. Everything must be, it must be completely open or bust or go away. You're not allowed to have your hardware certification number. Right? It's like, yep.
Yeah. Yep. Okay.
No, okay. You don't have to agree, but
it's not that Dave, I'm not saying that your thing doesn't solve a problem. I'm not saying that, there's a need for all this stuff. It's just like, literally, this doesn't, I don't know,
impact you, so you don't care.
This is not a hill I'm willing to die on. I guess that's what it really comes down to. And like you're saying though, some people are, right? And some people are like, this fits this criteria and this does not. And the one that does not allowed in our club. And you should not do this and this and this and this. And we're willing to take legal action. And at the end of the day, that's what really matters, right? Is like people are or are not willing to take legal action to do all this other stuff. And it's like, all right, that's when I usually throw my hands up and I'm like, this is not for me. So I love open source hardware. I love people that do it. I think it's an interesting concept because it does add on to stuff. One like more practical high level view I've taken on open source hardware in general is that it's not the most interesting hardware that's usually being open source. There is a lot of interesting open source hardware, but like the most interesting stuff is just not going to be open sourced. And so like I like it when it's out there. And like if you look at like if you looked at like a heat map of like open source hardware and like what's in open source hardware, I would estimate a guess, and I could be very wrong at this, that the heat map would be very strong around the Atmega 328. And like that alone is like, all right, well, cool. Like that's great. It's out there, but like that's less interesting to me. And so again, I'm glad it's out there. I think that's good for learning. I love that there's open information. I love looking at the schematics, but a lot of the schematics I've looked at have had a lot of Atmega 328s, and that's less interesting to me these days. So that's all I'm saying.
Right.
As a result, I am not willing to die on that hill because, okay, 328s.
It's not a hill anyone need die on. It's just a hill that needs to be there.
Mm-hmm.
You know, it's a hill that a lot of people want to stand on.
Sure, that's true.
Not fight, and why fight? It's like, well, there's a lot of people who want to do open source hardware the purest way, and there's others that want to have more practical oriented open. They want to share some stuff, but they don't want to share all, and there's some very good reasons for that, right?
Yep.
So
sure.
And there's no need for the two camps to even fight at all.
Okay.
So no, it's not a hill that you have to die on.
Yeah.
Yeah.
Chips that I'm not seeing on many open source hardware designs, but are interesting because they're not on any open source hardware designs mostly yet because this chip just came out, is the ESP32S2. Have you seen this thing?
No.
How was that for a segue? Was that okay?
Right. Yeah, that's fine.
Yeah.
But it's like, okay, grown. It's yet another thing. What's so special about it?
The interesting thing is that it was a downgrade of sorts. I talked to Jeroen about this. Sprite TM. He is one of the firmware software hardware guys there. He's the wizard there, one of the wizards there at Espressive. And basically they looked at the market, they looked at the part they had out there. It was the ESP32 is a dual core power hungry beast with a ULP, the ultra low power processor on it. So basically it's just a beast. It sucks down power, but it can do a lot of interesting things. This one is not dual core, so that's kind of interesting. So that's how it's kind of a downgrade in my opinion, because now you're not running on a second core. You're basically sharing time on the core that's running the Wi-Fi stack.
Mm-hmm.
It also has 2 low power processors in it now. One of them is a RISC-V. That's also interesting to me. What else do I remember from this Andreas Spies video that we'll be linking in here? That's the other one. It has a USB hub, not hub, USB. Help me out here, Dave. What's it called when you can just hook a USB with 2 lines
Host?
into a chip? Not a chip. It's a not a PHY. It's a thinking out loud here. I mean, it is USB host, but it's not a USB host. It's a USB device, but it is the physical stuff you need for USB.
Right.
Basically, just like on other parts where you can just hook up D plus D minus right into the chip.
Sure.
It has that now.
Well,
whereas
okay.
ESP32 didn't have that, and so you needed you needed another chip on there. So basically, now
I got it. Okay.
Now you can just drop this chip with a USB connector and be ready to go.
It's got a USB hardware core in it, and
yes. And so all those things are interesting. Still low power, still low cost rather. I haven't used it yet, but I think it's an interesting. I think the most interesting thing about it to me is the fact that it went from 2 cores to 1.
Okay.
And of sorts, right? Of the actual accessible normal cores that you're gonna use.
Mm-hmm.
So we'll see how it goes. It's new chips.
Cool.
New chips out there. Yeah. Speaking of chips, former guest of the show, Sam Zaloof, showed off how he does photolithography at home using his projector and does photolithography using that. That is also very worth using. So I guess we were talking about resources for building stuff at home. You're looking at the Google PDK and you're like, oh, that's too easy if they just give me the answers. Right. So now I should really build my own chips. You could follow Sam's steps, and you could do that at home now too. So that's another one.
Very cool. I think he's pretty much got that market to himself.
I think so.
There's not too many people willing to set up a chip fab in there.
Even Jerry Ellsworth has moved on to greener pastures there. So.
Yeah, exactly.
Sam posted the thing on Twitter the other day where he was actually playing a guitar pedal that he put together the chip to himself. That was very fun.
Yeah.
That was very fun.
Seriously, is he the only one in the world really the only amateur chip maker in the world? There's how many?
No, surely there's others. But they're probably not making YouTube videos about it.
No, probably not making. Yeah, they're not. Hope.
I bet there's a lot more after him. That's kind of interesting. Sam, if you're listening, keep going. It's
still the problem with it is that it's just such a high entry burden. It's just it's massive. You've got to have. Most people don't even have the space, let alone the ability. He's in the US, right? He can get a lot of this gear, right? Me in Australia, good luck, right? Even if I wanted to, even if I had the. I got the space to do it. Yeah. But I could not get the gear to do it. It'd be so prohibitive. I'd have to import it all from the US.
You should do that. Come on, man. What are you even doing here? Get on it, Dave.
It's Anyway, that stuff's much more readily available in the, there's all sorts of chip fabs closing down, and you can get, old chip fabs and things like that. And you just, at the auction sites, you just get all this gear and
I was watching, it was a very promo-y video. I think it was Kemet. We talk about trade on here, and the trade situation has not been getting better. There's a Steve Blank episode or post about the chip wars of 21st century. Well, he's a technologist, writer guy. He writes about startups a lot, but he's writing about this stuff.
Right.
But anyways, I was thinking about okay, so right now, if you wanted to build a capacitor factory in the US, what would that take? And then I saw a Kemet.
Right.
There was actually how they're made. It was a promo video or something like that.
Oh, excellent. Got to see it. Yeah.
Oh my God. No, I will not be starting a capacitor factory. Because they do 100% test. Holy shit. Can you imagine 100% test on 01005 capacitors and stuff like that?
You have to, because the tolerances are so ridiculously small that any production variation, fart halfway across the factory, it's going to change the process. It's and then you can get a huge number of failures if you're not. Of course, you got to keep on top of that.
And then schlubs like us were oh my God, this. They said it was 7% accurate, but we saw it was 7.5.
Oh boy. Yeah. I mean, caps have 5-10% tolerance for a reason.
Yeah.
It's
right.
yeah.
Yeah. I mean, with resistors, you're just chopping some off, right? It's just like, okay, you get material, what the
Right.
material is, you
Yeah.
mix it up,
Yeah.
chop it off,
That
and, put it in there.
multi-layer ceramic capacitors are.
I don't think I could start a resistor factory. Where the hell do you even start? Like you think about like all this conversation about like, okay, so there are some very, very big trade issues, and I think they're going to get worse. And yeah, we could talk about that all day long. But let's just say, yes, they are going to get worse. Yes, different countries need to have their own resources to do this thing. Where the hell do you start? I could maybe come up with an idea of like, at least with a semiconductor factory, you're like, yeah, I guess, you go buy old stuff, you start from there, right? And it's like, you could basically go to a Tel or who are the other chip machine makers folks? I don't know. I remember Tokyo Electron. I don't remember. I used to work in this industry, Dave.
Yeah, I know.
You could go and get a catalog from one of those Applied Materials. God damn it, got it. Applied Materials or Tel or whoever, and you could just go buy a bunch of machines. Where do you even start with resistors? It's just like, is there like a resistor, like a raw resistor factory? Just like a catalog of just like,
yeah.
I need a truck full of resistive material, please. You don't even know.
We have no idea. We just
like literally,
we take
we
it so
use these
for
things
granted
every single day. And I have no idea how this stuff works, Dave.
Yeah,
500 episodes in, this is what I've learned. I have no idea how anything works.
I have no idea how a resistor works.
I mean, I know that like there's a formula.
Right. It's called Ohm's law, and
I guess the first step would be like hire material scientists. That's probably the best first step. Be like, you guys know what you're doing, right? Like physics and how electrons move, and my goodness, we are dumb.
Yeah.
The thing that I love about electronics, though, there is so much shit to learn. I got some new boards, and I got some filters. I got some RF filters in. I got an RF amplifier, and it's under so I got an RF amplifier. It goes 10 megahertz to 8 gigahertz, right? And it does like 20 dB gain, 10 dB gain. And okay, cool. I bought it on Tindy. Works great. Looks awesome. It's under a little metal shield, right? And I'm like thinking about it. I'm like, what the hell is under that shield? I have no idea. How would you amplify that? Is it an op amp? I don't know. I'm going to have to rip this I'm going to break this thing now because I'm going to have to go rip the shield off, because I'm going to have to look at this. I don't know. I don't know how to amplify this many, like that wide of frequencies. And even if I did,
I'll tell you exactly what's in it. If you open it up, there is
it's gonna be a single transistor, right?
No, it'll be most likely a circular plastic package with 4 pins on it. There'll be power, ground, there'll be input and output pin, and they usually sit flat on the board. You often have to do a circular cutout. I can't remember the name of the package, right?
Right.
And it's and you feed in the power via an inductor. Right,
yep.
That's typically because they're designed for masthead amplifiers and stuff like that.
Block the high frequency. Yep.
Block the high frequencies, and passes the DC but doesn't let the RF through, and Bob's your uncle. That's it.
I just feel like when this kind of stuff happens,
gain chip in there.
After this, like talking about the chip, whatever the hell's in there, and then all of this stuff, like having Ming on the show last week too, like so much in electronics and technology too. I'm just like, man, we're like in a cargo cult, like we pay someone money, these little bits of sand show up at our doorstep in little packets, right? We get upset about how our magic robot doesn't work, right? There's a video about what's his name?
Oh, the Charm High. Yes.
There's a shit robot.
Maker.
It's a bad robot, right?
Yeah.
It's and it's it's a cargo. We live in a cargo cult. That's what it is, Dave.
Right.
But it is a wonderful cargo cult, and I really enjoy it a lot of times. Sometimes I hate it.
And given that this is the 500th episode, I have to bring it up because back right at the start, you said, we'll be making these chips with our own chip printer. You knew I was going to bring it up.
I knew you did. I knew you were going to bring it up because you said sometimes people make predictions, and it's the best if you forget them. It's the best if they forget them.
I'm not going to forget that, dude.
I was thinking in my head, who doesn't forget a prediction that I made? It's David L. Jones. That is the man.
I've got a memory like an elephant. Yep.
Yeah, that's great. Thanks, Dave. Okay, so 10 years later, we're here. I don't remember what the bet was, but double or nothing.
You said 10 years. You said there would be a chip printer in 10 years. I said you won't even get it in 20. That's BS, and I still stand behind that. You still won't have one in 20 years' time.
I
I'll
think
make the call again. You will not have a
double or
desktop
nothing.
chip printer.
Double or nothing. Double or nothing. Here's the thing. Ming was on the show last week, and I'd say that counts.
What?
So basically, it's putting silicon onto other silicon, and then you can do it via an interface. So it's basically like you're printing a new chip by. I'm just talking on my ass. I don't know. So basically, last week, I'm sure you haven't listened to the show yet. Last week, Ming
No, I haven't.
Zhang was on the show, and he was talking about Z glue, and basically, it's basically doing chiplets, and then they go on a substrate, and then basically you design the substrate, and then they have a tool that lets you make a package out of that. That is interesting. And I'm just going to say that's what I had in mind.
It's interesting, but yeah, the elephant in the room is DigiKey and Mouser, who have a couple of 100,000 off-the-shelf chips fully qualified in multiple packages that cost cents each. And you think that somebody's going to come up with a chip? It's ridiculous. It's the dumbest idea in history. It's not going to happen.
That is not the dumbest idea in history, and
You've worked in the chip. It is.
Dave,
well, no, it's not a dumb idea. It's great. It's not practical.
You watch the dumbest idea in history every Saturday whenever you watch these Amazon Prime movies. So let's just get that straight. It is not the dumbest idea in history.
Most impractical idea in industry. In history. It's not going to work.
I would say
you've worked in that. You know what goes into making a qualified chip.
It is increasingly unlikely that we will get it on our desktop. However, think of the other things we've talked about in this episode. Open source PDK, so people have access to chips factories.
Yeah.
So
fine. Yeah, of course.
There's more of that.
Yeah. Okay.
Dave, I'm grasping at straws here. Give me a little 500 friggin' episodes later. Give me a little wiggle room here.
No, none. You've already said it to yourself. It's acetone. The odds of a chip printer are asymptoting towards zero. And it was already there 10 years ago. You just wanted to hold out. So I'm gonna rub it in. I'm gonna continue to rub it in. I'm not gonna give you an inch.
Okay.
No.
All right, that's fine. But you know what? Here's the thing. If we hit a 30-year mark, by then who knows? Who knows, Dave?
No. Still calling.
Here's the other thing. Okay, so let's talk a little sci-fi stuff. People are like, click, end of episode. Some practical realities, right? So like, we're hopefully moving towards being a multiplanetary species.
Not going to happen.
Mr. Crazy Man Elon Musk is being crazy, very increasingly crazy. But I think it is likely that we're going to go back to the moon at some point, Mars, and whatever. Okay, so now maybe people are hanging out around Mars. Let's say 100 years from now, they're hanging out around Mars. They're maybe not living on Mars, but like, do you have to ship chips there? Like,
yes, yes, that's the whole point. You got to ship everything there. This is why a Mars colony is not going to work. I've done a video on this. It is because people don't realize that just the basic stuff.
Sci-fi books really gloss over that. Like, so I love the book Seven Eves. I've talked about it many times. They actually, so Stevenson does talk about it.
I've been meaning to read that.
Yeah. I think I've been talking about that for about 5 out of the 10 years here.
Yeah.
But he does talk about it. And he does talk about the main character. She basically has like a store of chips, and she like stores them inside like a metal asteroid that they're hanging out on, that she has like a little compartment in there to like radiation shielding. That part is fantastic. But then somehow a culture springs up later, and it's like, okay, all right, well, okay.
Well, the whole chip printer thing, I used to love this series. I can't remember what it was called, but it was where they went back into the time and there were dinosaurs. And they went and they set up a colony back in
Land of the Lost.
It's
you want to watch some bad movies / TV, Land of the Lost is it.
Right. They had a chip printer. They famously had a chip printer because they took because they have to repair stuff back in there. So they had this chip printer that they could print replacement chips to keep all this stuff going. And people don't realize a Mars colony, people don't appreciate the massive, not only the manufacturing infrastructure, but the logistics infrastructure and everything else that goes into just making the bare necessities to keep you alive, let alone all your fancy stuff like your bloody iPhones, right? People don't realize you can't replicate that on Mars. Everything will still have to come from Earth. You can't do it. You can't do it.
There is channel?
You can't get a self-sustaining colony on Mars. It's not possible. They'll just die out without replacements from Earth. Simple as that. And that's going to be the same. That's going to be like that for hundreds of years.
Yeah.
Hundreds. And you have to so massively terraform it that then you can produce all the same, even the basic necessities here. People take their clothes for granted. You know how much effort goes into producing clothes? You know how much infrastructure that goes into producing just the basic stuff, right? Unless you want to walk around, naked and with just your farming and just eating your Mars. No, roam around naked eating your growing your beans you've grown in your greenhouse or whatever, and that's it. That's your entire life.
Your crap potatoes.
Yeah, exactly. And that's it. I mean, it's just ludicrous. People aren't practical enough. They don't think about the practicalities of it.
Well, Dave, we have to drive towards that. I think
anyway.
I think there's some.
Of course, we have to drive towards it. I'm not saying don't. I'm not saying don't do it. I'm not saying we'll probably be on Mars in the next 20 years. I'm not saying we won't. We definitely will. But I mean,
you're just saying they're gonna pack a lunch. You're saying they're gonna
bring
a picnic.
Yep. It's no, they cannot survive without replenishments from here. It's just not going to happen. So unfortunately, I would love. Like, I'm huge. Like, you won't get a bigger space buff than me, right? Who wants to? I want to believe in the Mars colony. A moon colony will happen before a Mars colony happens because it's so close. We can just get send freight up there in a couple of days, right? It's easy.
Yeah. Yep.
Yep.
Well,
calm down now.
That was a bit of a downer.
What?
It's a bit of a downer, Dave.
I'm sorry. I'm a practical engineer. Sue me. This is an engineering podcast. It's like practicalities matter. Like, this isn't fantasy podcast.
Yes. I know. Hey, look. I will start a fantasy podcast in a second. I will talk about sci-fi all day long.
Listen to it. Yeah, go for it.
The Bobaverse. Read the Bobaverse. I love it. The Bobaverse.
What's the Bobaverse?
I've talked about the Bobaverse on here before. It's a 3-book series. It's about a guy that dies in like the first chapter, but his brain
thanks for the spoiler.
An AI in the future, basically, and then he kind of goes to so basically because he's an AI or he's like his brain is like captured in a computer, he can replicate himself, and then he goes and takes over the stars. It's awesome. It's a great book.
Right.
It's a great 3 books. I love it. Go read it. Listen to it. It's actually even better as an audiobook.
Okay.
Great book. Great set of books.
I can't read at the moment. My Kindle's dead.
Well, yeah, you should listen to them, Dave. Listen to books.
Yeah, okay.
Just especially people listen to this thing. If you like podcasts, you're going to love audiobooks.
Yep. Agreed. Yeah, I do enjoy audiobooks. I prefer it when it's spoken by the author, though.
Yeah, sometimes, not always.
Yeah, not always. Some authors suck,
I think like nonfiction for sure. But like fiction, no, I want like a voice actor.
All right.
I talked about on here, I think it was with a guest, or maybe it was when just a guest co-host or something. But the idea of like having podcasts where like you read technical papers, like having like audio-based like technical resources.
Reading
like not like abstract, see figure 1.4.8, but like actual like technical. I don't know. It was like based off the idea of like Autumn, which is I don't think I heard back from anyone about it. I like mentioned it on here. No one said anything they're interested about it, so I kind of dropped it. But I still like that idea of like listening to technical content and like being able to like capture, somewhat complex. It's really going to be pointers towards complex content because I don't think that it's possible to really dig in deep. Like I said.
No, but you need like a summary. You need if you reckon there's a niche out there for a podcast of like a summary of. Well, I kind of watch a guy on YouTube, Anton Petrov. What the math it's called. What the math. Anyways, channel's called Anton Petrov, and he basically does that. Like every day he releases like a space science related video where he just talks about like a latest research paper that's been released, but he animates.
What if you fell into Saturn? That's cool.
yeah. Like there's like but they're all based. Every episode's like usually based on like recent research, and he links to the publication. So if you want to go read the publication, you can. If you want to go read the paper, you can. But he just gives you like a overall summary and tries to simulate how this new neutron star
that's cool
spins and all sorts of stuff. Yeah, I'm totally addicted to that.
Yeah, that's great. Yeah, so like that kind of thing, like basically like reading abstracts but also contextualizing it, right? So like
right, yes, you got to make it exciting.
This is interesting because it's a wide range of topics.
Hard to do it as a podcast. It's more easier to do it with visual. stuff.
Especially when we don't read the articles beforehand. Don't forget about that, Dave.
Yeah, right. So yeah, no, there's I agree. There could be a niche out there for people reading papers and the latest papers, and and pulling out the interesting stuff. But you've got to make it exciting. So that's the trick. That's the ticket, laddie. Make it exciting.
Anecdotes, Dave.
Anecdotes.
That's what people like.
Right.
That's what people like.
That's what the young folks like these days.
Are there any other anecdotes we should be talking about here on or I guess links? We have like 4 weeks worth of links. So,
yeah, we did because we were, I don't know, just didn't do a show for 4 weeks or something. Don't know why.
Here's some so basically I've been dumping links in here as I find them. So like a lot of them are RF based right now, but there's an RF PCB simulation cookbook from TI. I'll link that. That's pretty cool. And some of these are like, I go and look at them to dig in later.
Yep.
KiCad has some new RF tools because they're not great with RF yet, but those are interesting. What else? There was the Navy Electricity and Electronics Trading Series.
Oh, they've got they've released all the training material or whatever.
Yeah, that's cool.
Yep.
And then there was one other one. Oh, it was from Contiki, IoT in 5 days. I thought this was interesting. So it's like an ebook almost. And basically Contiki is like one of the it's
a tour group as far as I know.
Yeah, right. They also do that. Yeah.
Right.
I mean, that's also the same name. I'm not sure what Contiki stands for. But this is basically like they go through sensors and like so Contiki is an OS, and then basically they talk about sensors and how to set up wireless and all the different things. But it's like kind of just a good overall look at like building a small wireless system with sensors, including up through like using Contiki to talk over IPv6 and things like that. So like that's a very tall stack, I think, to go from low level hardware all the way up to sending packets, but I think that actually resonates a lot with
that document's very comprehensive.
Yeah.
It looks very wow. Yeah. Someone's put a lot of work into that. Multiple people have put.
Yep. People in Italy. It's a school, I think. So
there are Italian names. Yep.
Yeah. .it is the domain. So that
anyway,
helps.
LinkedIn,
but it's from 2015, so keep that in mind. That it's an old thing, but it checks out. Boy. So that's. Oh, and then here's one other one. I guess is a video. I mean, I'm always linking to Alan Wolke's stuff. Alan's been on the show before. I've talked to him about coming back on. He said he's very busy right now. So, but his stuff is amazing.
I know you're fanboying over his VNA stuff.
I mean, it's great. It's great. Like, I wish it was there. I wish it was there before I bought mine. You know what I mean?
Right,
like, that's what I've learned this stuff through like talking to Jeff Kaiser a lot, and just struggling. Someone asked me today, like, how have I learned RF? And I was like, oh, well, usually I buy something and then I struggle to use it, and then I call a friend, and then I ask on Twitter. And then I go back and like just the usual way of learning things.
Right.
I guess. Yeah.
And there's an interactive guide to Maxwell's equations for all you Maxwell fanboys if you just can't get enough of those weird symbols,
Curl. Give me the curl, man. Got to do my curls. hit the Maxwell gym.
Yeah, it's like, there's fun bedtime reading right there, Maxwell.
Yeah, because you will be out.
Yeah, there's some people who just love that stuff. I was never into, that just wasn't a thing for me.
Okay, one last thing about books. I'm reading a book right now called Ultra Learning, and he talks about transference. And this is like an argument against like traditional education. It's that transference has been like disproven actually in different studies.
What transference are we talking about?
So like transference would be, okay, so you go and sit in a class.
Of the information into your brain, processed into your brain.
No, that is a type of transference, but no, this is actually like the assumption that learning the theory and then being able to then take okay, let's talk about Ohm's law, right?
Yeah.
You go and sit in a classroom and you do all the math and you learn Ohm's law, and the transference is the assumption that you will then go and be able to use that in the lab and basically apply this abstract concept to a very physical, hard, real world thing. And that has been disproven many things. And I'm of course going to talk about books that resonate with me. This book is just like, it's got my, contextual, alarm bells ringing.
Of course.
So like, take that with a grain of salt. But it's an interesting book. And the thing I like most about it is it's very practical. It gives you like different things you can do. Like it talks about creating drills for yourself, like you might with a sport or music or something like that.
Right. Okay.
And things that like, with like electronics, what do drills look like for electronics? It's like, oh, okay. And so I've just been kind of thinking through that, and it might become part of contextual electronics at some point, but it's a very interesting concept that I don't see talked about too much, other than like make more circuit boards or do more electronics is like more drills, but that's not very specified. So I think that's a good topic for a future show of like, what do drills and electronics look like? And I'd love to hear from people if they have thoughts.
Well, you dribble the electrons over here, and then you dribble this way, and you pass
That's
that
right.
way. And you...
That's right. You got to do fancy footwork. Don't forget about that.
Interesting.
Oh, shit. One last thing. I'm sorry. I've been swearing a lot this episode. There is a giveaway. We have a giveaway. So this is actually, this is an interesting, I should have put this on the list, but it is called the Quick Feather. And this is a new type of chip. I have to send you the link real quick.
I've got it.
You do? Okay, great. So it's a new type of chip the chip doesn't seem like the company doesn't seem like it's going to stick around that long. And I hesitate to say that just because like Quick Logic, it just sounds like, I'm sure it just seems like they're not going to be around long, just given that name. For some reason, it just strikes me as like it's I'm sure they've been around. I'm sure they're fine, Chris. Right? I know I sound like a mean person, but basically it's a dev board for this chip, and it's got an integrate. So it's basically a Cortex M4 with an FPGA built into it, right? And so basically it's like flexible fabric, and the whole idea is it's like a chip that's meant to like process.
Oh, so the Quick Logic, it's the Quick Logic EOS S3 chip.
That's right.
Yes. So it's a system on chip. Okay, so they've done their own, right? Okay,
exactly. And so like it's like specified to be like for like machine learning type of thing. So if you had like a microphone, it has like a microphone input for it, right? And then that goes into a bit of I think hard logic that then you can then connect to with the FPGA fabric. And basically, so it's like a design that this company had made that basically is they bought the ARM core, they put some flexible logic around it, and they built these custom blocks that do a bunch of different things. It's meant to be like it handles different functions for, IoT type devices and stuff like that. And edge AI and ML, blah, 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 blah.
And we're giving one away, are we?
We're giving one away.
How do we do that?
I'm going to come up with a questionnaire. And if you fill it out, one person will be sent one of these things. So it'll probably be about learning or something like that. We've done that in the past. But I did say I'd give one away, and we can ship anywhere in the world. So that's not a problem. And it looks like a cool board. It's also like I think they're on it. This is I'm interacting with the Crowd Supply folks. So that's who
Crowd Supply. Yes, it's on Crowd Supply. Yep, it got funded.
Yeah. Yep. Yes. Yep. I think it was a $1. $1.
You goal.
$1 goal. Yeah.
Goal.
So, okay.
Smash
we
that
knew,
goal.
we knew I was gonna. Yeah. 23,000. 23,000% funded or whatever it is.
Yeah. Nice.
Yeah.
All right.
Okay.
Cool.
Well, that's it.
That's it. Well, that's it for the show.
Half a order of magnitude over.
Yep.
Yeah.
Half an order. Yep. Near enough.
Would an order of magnitude be like if you're going from 10 to 1,000 though?
Well,
so wouldn't it be
two
like
orders of magnitude?
That's 2 orders of magnitude.
And an order of magnitude more than 10 times is 100, and then 2 orders of magnitude is 1,000.
Right.
2 orders of magnitude.
But like 500 wouldn't really be half an order of magnitude, would it? I mean, it's like.
Oh no. It depends what your baseline is, right?
Right. Yeah.
If your baseline's 1,000.
This is just me getting back at you for the.
Okay. I get you. Yeah.
Be like 450 would have been like half. Yeah. Anyways.
But once again, it's we're going to the order. Going to half an order. It's near enough.
I think we could just say 500 is pretty cool. So congrats, Dave. We did it. We got to 5. Let's say 512 though. Let's get to 512.
Woo! Yeah. Party poppers. The excitement is palpable. It's just... That's it. Yep. Show over. Catch you next time.
Yep. See ya.